So this is going to be our data path component, our counter, which is going to take into account the total amount of money in the vending machine, as well as the total items purchased and the total items remaining. So it's important to note that our total items remaining is going to be set to 15, which is also going to happen when reset is equal to 1, because that just lets us know that our vending machine has been restocked. Our total items purchased will be 0, and our total amount in the vending machine will be 0. So on a rising clock edge, if we're going to check to see if it's purchased, an item is purchased, which will be received from the finite state machine. However, because we're just running the counter separately, it's not going to be based on the state transition. So if the items purchased is equal to 15, which means we've purchased all the items, and the items remaining is equal to 0, meaning that we have no items left to restock, to give out, then we're going to restock our vending machine, and items purchased will be equal to 0, and items remaining will be equal to 15 again. If this occurrence does not happen, then we will increment items purchased and we will decrement items remaining. And if items purchased is equal to 0, we will just hold those values. As far as the total amount, if a nickel is inserted into our vending machine, then our total amount will increment by 5, and this is 5 in the binary. Else, if a dime is entered into our vending machine, then our total amount of money in the vending machine will be equal to 10, or we'll add 10 to our already existing total. And then here is us tying our signals back to our outputs. So let's look at our simulation waves. And just remember to take note that our purchased items is not going to be based off of the amount of money put in the state transitions, because our FSM is not involved. We're just testing the counter. So whenever an item is purchased, when purchase is equal to 1, then we're going to increment our purchased items and decrement our remaining items. So let's just take that into account. So when we start, our reset is equal to 1. So as said before, the total amount is 0, and our item purchased is 0, as well as our remaining items is equal to 15. On the first positive clock edge, we're going to receive a dime. So our total amount is going to be 10 cents here. And then our item purchased and our item remaining is going to stay the same, because purchased is equal to 0. So we haven't received an item purchased. On the next clock edge, we see that a nickel has been inserted, which means that our total amount should be 15, which we see here. And it's still items purchased and items remaining have not changed, because purchase is still 0. On the next positive clock edge, we see here that purchases still had not changed, so item purchase and remaining are the same. Total amount is going to be incremented by a dime. Let's see, what did we have originally? 10. So this is 20 cents. And so then on the next positive clock edge, I think I skipped one, my bad. 15. Oh, right. So the last one was 15. So now we added, it's going to be, a dime is going to be 25, my bad. And so this is going to continue to occur, as you can see. As we receive nickels and dimes, it's going to increment as such, and also take into account, because we have only 5 bits, the 6th bit will be truncated, so we won't be able to see that, but it's still adding accordingly. We're just missing that extra bit. So let's see what happens when purchase is equal to 1. When purchase is equal to 1, then an item will be purchased, so it's incrementing by 1, and then an item remaining will be taken away, so it is decremented by 1. And that happens on every positive clock edge as the purchase stays 1. So we can see as it incremented by 1 again, making the item number purchased 2, and making the items remaining 13. And we can just see how that works there. Now it is 3, and items remaining is 12. notice how the total amount is still incrementing based on the dimes. Let's go here. So we can see our last time we purchased something, we have 6 items purchased and 9 items remaining. Once purchase is no longer 1, then the number of values should not change, which it didn't. So now we see that our counter works properly and gives us the correct outputs.